Okay, so this is Mathematician Jeff again, continuing from our last video where we were looking at types of equations. We're now going into solving linear equations. The goal is to go to each level, and we're going to see how we can solve different degrees of polynomials. Right now we're starting off with linear equations. I'm going to show you how to solve some equations today. First thing I'm going to go off here is real quick is a little recap. We want to make sure that we recall the words order and linear. So from my last video, if you haven't watched it, we looked at the words order. Order refers to the highest degree. It means the number of solutions in a polynomial. And it does help us tell end behavior, which we aren't there to yet, but it just is a fun, part of the definition that is in there. And linear refers to the highest degree, that highest exponent, being 1 in a polynomial. And we're looking at just the variables, I should say, just the variables. Now, let's go into some of the types of solving methods that we have. So there's two main types of solving linear equations. We're going to get to systems of equations soon, but I figure for this video, we're not going to talk about a system yet. We're going to learn how we can solve equations directly and their types before we get into multiple equations. So there's two main types. We have direct solving, and generally that's with an equal sign, and inequalities are where we have those less than or greater thans. And let's just make sure we understand real quick. So direct solving is where you have an equation that you can just solve directly for x. Now, the reason why this is good for linear equations with that degree 1 are kind of the most basic form of equations, right? The highest degree is 1, which means we don't need to do any fancy steps like working with exponents or other functions that require us to undo those processes, right? Because when I want to solve for x, I want to see just x. I don't want to see 2x. I don't want to see x squared. And the easiest example I always say is let x be the price of your favorite candy bar, right? If you're at the store and you see your favorite candy bar, and let's just say for the easiest method here, your favorite candy bar is $1, right? Your favorite candy bar is $1, right? And if you see that, right, you should know one candy bar is $1, right? But let's say they kind of changed that price tag and said, hey, it's they don't tell you the price, they just say, hey, the price is exactly 2 times the price squared. And you're like, I have to do math to figure this out? Oh no. Yeah, we don't really want that, right? We want to see just classic, good old-fashioned x is equal to some number, and that lets me know this is exactly what I'm looking for, right? No scaled versions of it. Hey, that candy bar price is the price of 2 candy bars. Okay. Okay, or we could say, well, that price of this candy bar is actually half of this price. Okay, wouldn't you just want to write half the price then? Why do I have to do that work? It's the same thing. So I don't want to see a 1/2 x. I don't want to see a 2x. I don't want to see x cubed, right? I don't want to have to do operations to figure out that price, right? I just want to see the price. So this is where we get into direct solving, right? Direct solving is really nice with linear equations because there's nothing really fancy I need to do. It's a degree 1 already, and degree 1 doesn't really need much work with the variable. All I need to do then is go to the order of operations and solve my equation with the proper steps. Now, let me just quickly briefly remind you of what the order of operations are, and to prove to you this is the exact way you're supposed to do it. So if you are in America, like myself, we generally refer to as PEMDAS, right? So PEMDAS is the classic version of it. Please excuse my dear Aunt Sally, which I'm sure you're like, okay, yeah, I've seen this before. But there's one thing I want to show you. Most people do mix up the order of operations. P stands for parentheses. E is the exponents, and then we say MD and then AS. And one thing that we want to say here, and a lot of people mess this up, is they do multiplication before division, and that's simply not true. I put in a note here. We want to work with our operations from left to right, whichever comes first, and that is very true. So from left to right, whichever comes first, left to right, whichever comes first. So my meaning for this here is multiplication and division and addition and subtraction are the same exact rank, but from left to right. And to prove it to you, there's a European acronym which is very similar to PEMDAS. They call it BODIMUS. And BODIMUS stands for brackets, which is parentheses, operations, like exponents, and then they say DM, and then AS. So for those of you that say, I'm used to the order of operations being multiplication must always come first. Well, that's not necessarily true. Look at the Europeans. They say D, then M. And wouldn't that contradict it? That would. So it doesn't matter if you use PEMDAS or if you use BODAMIS, right? BODAMIS. Because you're doing the same operations, but from left to right, whichever does come first. And I just want to make sure you're aware of that, all right? Left to right, whichever comes first. So let's go see if we can simplify some equations using some of these operations. And I have some examples down here, some basic ones. Number one, I see 3x plus 2 equals 11, and I want to solve this for x. And just like before, I see a 3x. Again, if that's my price tag of the candy bar, if x is whatever that price is, x could be 32, x could be 10. I would hope not a $32 candy bar. Maybe $1, maybe $2. I want to just have x, right? If my price tag, let's say x was equal to let's say x was equal to, let's say 33 cents, right? I don't want to have to multiply it by 3 and get 99 cents. Just show me the price, right? I don't want to see these extra numbers. So we got to get rid of them. My personal advice is to try to isolate the variable with x as best as you can from the start, and then use your operations. So let's start with this. So even though the order of operations say a hierarchy, right, when simplifying, we could still use these same rankings at that piece there, right? So I'm going to start with addition and subtraction, just because even though those are a hierarchy step, that's for simplifying. We want to solve, but we're going to still use the order of operations, only we're solving, not simplifying. Simplifying is different if I have, say, hey, let's do 3 squared minus, I could say minus 4 plus 2, right? That's simplification. There's no x in there, there's no solving, there's no equal sign, and that's something to be aware of. I'll give you one fun fact. The difference between an expression and an equation is an equal sign. And in this one up here, I don't have an equal sign. Therefore, it's got to be an expression. In example 1 and 2, I got an equal sign, which means I got an equation, which means I got to solve. So in here, I'm going to subtract 2 from both sides, right? I want to get x as by itself as best as I can. And one thing to denote, if you remember from previous video, right? So from our previous video, remember I talked about implicit versus explicit equations, right? I talked about these both. And one thing to denote here is you should recall that this is, there is no other variables in here, right? There are no other variables in here, but it kind of is looking a little bit closer to implicit, right? There might not be a variable there, but the one thing to denote is x isn't by itself, right? We want to get it into that explicit form, which is x equals stuff. And that's exactly what I'm going to try to do, which is why I'm subtracting 2 to get x by itself as best as I can. So I can get 3x is equal to 9. And then whenever I told you there is a variable directly against the number, that means multiplication. And as we go on further, we don't use the x as multiplication anymore because this is a variable. We go to the little dot. So dot means multiplication, right? We like to do that. So multiplication, and we go from there. So I'm going to divide by 3 as the opposite of multiplication. Divide by 3, cancel out. X is equal to 3, right? Because I did the opposite operation. Now to prevent this video from going super fast, you can pause the video and rewind these steps to see these help you out here on YouTube. Alright, the next step here. I got negative 2x plus 8 is equal to 18. Well, I'm going to try to get x all by itself as best as I can. So I'm going to subtract 8, subtract 8. Negative 2x is equal to 10. And again, that operation of a 2 means negative 2 times the x. So I'm going to do the opposite and divide by negative 2. Divide by negative 2. These cancel, and x will equal negative 5. All right, I'm solving directly for x. The last one down here does look a little scary. Only this one has fractions. Now here's the key with fractions. You could either do 2 steps. You could add the 3 to the other side, and we could add these fractions together, right? Only then you have to add and subtract fractions, which I know is everyone's favorite. Now, if you want to do that, we can. And if I were to, we'd have to work with least common denominators. If you want a video on fractions, please give me a nice little like. And this is my way of giving a thumbs up. Give me a thumbs up if you want to see a video on fractions, adding and subtracting fractions. But if not, we'll take the opposite operation here. Let's see if we can combine and get rid of the fraction. So the easiest way is to multiply by the number in the denominator, and generally the highest number in the denominator. In this case, I got two fractions, and they're both 2's, so not much I really got to worry about here. But I'm going to multiply by the largest denominator. In this case, it's 2. So I'm going to take my 1/2 x minus 3 is equal to 5/2, and I'm going to multiply everything by that denominator 2. And I'm allowed to do this, right? Because if 2 is being multiplied on one side, 2 is being multiplied on the other side, you know, that's like me saying, hey, 3 is equal to 3, and I say, well, let's multiply this by 2, and let's multiply this by 2, and that works out very well, right? So that is technically a legal move. This is 6, this is 6, I'm allowed to do that. So I'm going to multiply by 2, and hopefully you remember your distributive property, right? Distributive property means I want to distribute that operation into everything, which means 2 times 1/2 are going to cancel each other out. 2 divided by 2x, 2 minus 6, right? 2 times 3 is 6, is equal to 5 times 2 is 10. Divided by 2, I can now reduce this, cancel out. 2 divided by 2 is 1, I just have x, minus 6 is equal to 5. Now, in case you don't know here, right, you don't have to write 1, right? 2 divided by 2 is just 1. I don't have to write it, but you can if you like. I'm not going to write it. And then all I got to do is add 6 to the other side, and I have x is equal to 11. So you see what I did there? I got rid of the denominator by just multiplying by what it was in the denominator. And I had to do it to both sides. That got rid of the fraction. I was then working with whole numbers at that point, right? Because I got a 1 here, I got a -6, a +5. That made my life a lot easier. And that's where I went from there. Okay? Okay. Again, if you want to see a video on fractions, please comment below. Give me a like, something that lets me know you want to see it, and I will happily make a video on it. I'm trying to make a video each day. Let's see the last part here, which is inequalities, the other type. So generally up above here, direct solving solves for x is equal to exactly some number. And I want you to mean exactly, right? Equals means exactly, which means I want to see exactly this number. Only with inequalities, these either have a greater than, a less than, maybe a greater than or equal to, or a less than or equal to. And what do these mean? These basically say, hey, I'm taking a survey of people, right? Maybe I work for, a TV studio, and I'm saying, hey, I want to survey some kids and see what their favorite TV shows are, so that way I can market and tell my network what shows we should be putting on the air more often so they watch our network, right? That's a classic example. And if we send out, say, an email survey, maybe I don't want to just look at kids that are equal to exactly, 7 years old. Maybe there's teenagers that watch, old other sitcoms on there. So maybe we want to say x is greater than 7, right? Hey, you can be 7 years old or bigger. But wait a minute, that gets into a problem. This symbol specifically means strictly. And I'm going to write that down here. This means strictly. And that's a real word for this, right? Strictly. Meaning I specifically have to be bigger than 7. I can't be 7, right? Because it means strictly bigger. So 8 or 9 or 10, but not 7. So this is where they take the inequality plus an equal sign and they kind of mash it together and they create a greater than or equal to, which transforms into x is greater than or equal to 7, which means 7 or larger. Sound cool? So let's see here. With these inequalities, there are a few extra rules. Whenever we multiply or divide by a negative sign, we have no choice but to flip the sign. Let's see some examples here, right? If I want to do this, the only small part here that's new here is whenever you have multiple x's, you have to combine them, right? I don't want my price mixed up. I have to combine all of the prices. So I'm going to subtract the 2x and subtract the 2x first to combine those. 2 minus 3 is 1. I get x minus 5 is less than or equal to a +7 here. And then all I have to do is add 5 add 5, x is less than or equal to 12. Pretty cool. The last one I have on here is going to be fractions. Again, we're following the same rules as before. However, we still got to make sure we respect that negative sign flip if there is one. Let's see if there is. Let's see. I'll let you figure it out. In this problem here, I have two fractions. And my trick here is I want to multiply by the larger denominator, which in this case would be 3. And sometimes that might help you, but sometimes that might not. Let's try it out. If I multiply by 3, okay, that'll cancel out the 2/3, right? But if I multiply a 3 by a half, it's not going to cancel it. It's going to get me a 3/2. It's not going to work. So what do you do in this situation then? I said multiply by the largest, denominator, but it's not working. In this case here, you need to use what's called a least common denominator, LCD, least common denominator. And that's where you take each of those denominators, 3 and 2, and you multiply them to get 6. Now I multiply everything by that number, and it will surely cancel it out. So I'm going to rewrite the problem here to 2/3 x plus 4 is greater than 1/2 x minus 1. I'm going to multiply all sides by that number, which is 6, and the number 6. If I distribute, 6 times 2 is 12 over 3, 4 is the x, and then 6 times 4 is going to be plus 24, greater than 6 and 6. I'm going to get 6 times 1 is 6 over 2x. Negative 1 and 6 makes minus 6. If I then simplify this, and here I'll scroll down here, 12 divided by 3 is 4x, and I'm going to get plus 24 still, greater than 6 and 2 make 3x minus 6. We now have a standard problem like before, and I'm going to combine like terms. Combine the 3x, combine the 3x, right? I'm going to subtract it to the other side. And the reason I chose the 3 is because I like to avoid negative numbers, right? 3 minus a 4 is a negative. I want to avoid those if I can. So subtract, I get x plus 24 is greater than negative 6. And the last step is to subtract 24. Subtract 24. And I'm going to let those reduce out. X is greater than a negative 30. And that's it. That's it. So I have these two examples on here to get us started. If you want to see more of linear equations, I'm going to continue on with quadratics next. If there is anything in specific you want to see, I can show you anything even up to the graduate level, linear algebra, abstract algebra. We can see calculus 1, 2, and 3. We can even see vector calculus, even differential equations. So if there's something in specific you want to see, otherwise I'm going to go in order and start from algebra, and I'll see you in quadratics in the next video. Thank you, everybody.